Good afternoon. My name is Agnieszka and I work at an imaging lab in Singapore. But today I will speak to you about the 3D center that we established back in Switzerland because as you guys might find out one day, if you ever start a 3D lab, you continue being involved in it no matter what, even if you run across the ocean. So forensics is a difficult field, mostly because there is two types of professionals involved that are very different in their agenda, in the way they think, in the way they communicate even. You've got medical professionals and you've got police officers. So if you remember Eric's presentation from yesterday, that was our why. We never started with wanting to set up a 3D center. We started by looking at there is a problem here because those two groups don't communicate well, don't work well, and we needed to solve this problem somehow. And as a result, we decided to get a couple of people from the Forensic Medicine Institute and a couple of people from the city police and work together on establishing a technical innovation center that would combine the knowledge that comes from those two places. So there was already a lot of innovation happening within the city police, so we decided to utilize that. They have some amazing 3D scanners that they've been using to document the crime scene. So we started to first facilitate the workflow, and we decided to leave the crime scene documentation to them, then to leave the medical imaging to the medical professionals, and we assisted with developing that technology further and establishing some other robotic systems for them to automate that. And then we are combining all that information in our new 3D center to do the entire crime scene investigation in virtual reality, basically. So I'll just very quickly show you how that works. This is what the police would do. They would arrive at the scene and they would document the entire thing in 3D. These are the kind of results that they're getting from their optical scanners, up to the scale of the entire street sometimes, if that was necessary. The biggest model we've ever done was for a hot air balloon crash, for which we had to simulate the entire journey of the hot air balloon, which included half of the mountain. And this is the Forensic Medicine Institute. So you have the regular setup of a CT scan, which is the B, and then an A is the robotic system that we have incorporated into the regular CT scanner. So that included the optical scanner for the entire surface documentation of the body that was on the CT bench, and the photogrammetry procedure that is including the same robotic system that is controlling the scanner here, was also controlling the camera for a full texturized model. So this is how it looks. This is the automation process, so that you can set this up and then go get a coffee, and 20 minutes later you've got the entire scan of the whole body. This is the photogrammetry procedure that was already introduced today, and this is the result that we're getting. So we would use that for a bunch of different investigations. This is our CT combined with the surface documentation, which is not as common in the medical investigation, because you don't need the surface information as much as in forensics. And then we would take all that and put it into dynamic simulations, which I don't really have time to show today, but these are just the snapshots of those simulations. So we've got anything from the shooting scenes to traffic accidents and anything in between. And this is one of the cases that weren't presented anywhere yet. So this is an extensive skull violation that we were asked to simulate in 3D because it wasn't obvious from the crime scene what happened. So we started with our standard CT scan that is now part of the everyday workflow. We get a CT scan before we do anything else from the entire skull, but it was in so many pieces we couldn't see at all what was happening. So we took it out, and after the maceration process that yielded 67 bone fragments, I scanned every single one of them separately, segmented them, and then I put it into the Gong software, which allows for a I think, for the best alignment process that can be used for basically puzzle work. So you use the 3-point alignment to put together piece by piece all that you have from the skull, and then you use the best fit function to help it fit as well as possible. And after that, you end up with having 2 skull models. One is the one that is with all the fractures, and the other one is the one that you reconstructed and is of the full skull the way it should be. And then you begin the actual medical examination within the software. So that's the part where the doctors came in, the pathologists came in, and looked at the overlap between the skull, how it should be, and the skull, how it ended up, and started to brainstorm what could have caused that and what kind of injury was that really that we were looking at. And this is the end result of this, which again, I can't show you the video of. I also don't have the permission for that. But as a result of that, we could identify what could be the potential weapon for this kind of injury, and then we run simulations in 3ds Max to compare the two and see whether this could be that. Normally, we would proceed with printing this out, as printing out the skull for presentation, but this was already sufficient to get a confession, so we didn't have to proceed any further. But this is what we would normally do. So for a presentation in court, we would print out the skull and then use that as an evidence. And this is just a quick summary of what you can use 3D technology for in forensics. And why is it important? Because you can experiment so much more than in medical science, because you have much more time to play with. You can, in terms of technology, you can't really use your CT scanner the same way in medical science as you can in forensics, because I can basically max up the scanner and get the best quality image possible. The scale is very wide, so you can run a lot of different projects, and you can try things out that you wouldn't normally try out in medicine. And there is much more open communication about it, because there are so many professionals who aren't medical professionals that are involved, like the lawyers or prosecutors who have the clearance to look at the data and give you their feedback. And so that's why I think it's important for us to reach out to those other fields that might have use for our skills and our skill set and 3D methods. Thank you.